Hi guys, this is Miss Gold. Today's lesson is Module 3, Lesson 15, Surface Area. Your outcomes for today's lesson are students find the surface area of three-dimensional objects whose surface area is composed of triangles and quadrilaterals. They use polyhedron nets to understand that surface area is simply the sum of the area of the lateral faces and the area of the bases. Let's start by taking a look at example 1, lateral area of a right prism. A right triangular prism, a right rectangular prism, and a right pentagonal prism are pictured below and all have equal heights of h. Write an expression that represents the lateral area of the right triangular prism as the sum of the areas of its lateral faces. The first thing we need to understand here is the vocabulary term lateral area. The lateral area excludes the area of the top and bottom figure here, in this case, this triangle here, and this triangle here. So when we're asking for the lateral area, we're really adding up all of the faces excluding the base and the top. So part A, again, said to write an expression that represents the lateral area of the right triangular prism as the sum of the area of its lateral faces. So to find the lateral area, we are going to add up all of the faces. So here we can see we have this face back here. Let's call this 1. We have this face back here. We'll call that 2. And then we have this front face here. We'll call that 3. So my approach here is basically to find the area of 1, add it to the area of 2, and then to the area of 3. Now in each of these, the faces are made up of rectangles. So we know the area of a rectangle is base times height. So in this case, area 1 would consist of a base of length A and a height of h. So that would be A times h. The area of figure 2 has a base of B and a height of h as well, B h. And finally, figure 3 has a base length of C and a height of h, making its area CH. Part B says write an expression that represents the lateral area of the right rectangular prism as the sum of its areas of its lateral faces. So again, we're going to find the lateral area by adding up all of the faces of our right rectangular prism. Now, the faces of our right rectangular prism are also rectangles. And what we should notice here is that we have 4 faces. 1, which is this face over here. 2, which is this face back here. 3, which is this face right here. And 4, which is our front face here. Now, one thing that I noticed, because it is a right rectangular prism, I know that 1 and 3 have the same area and 2 and 4 also have the same area. So I can take that into account when I go to add up my faces. My approach is to do 2 times the area of face 1 plus 2 times the area of face 2. Now again, looking back at our figure, you can see that 1, when I say 2 times, that covers both 1 and 3. And when I say the area of 2, that covers both the front and the back, so that covers the area of 2 and 4. So we're going to have 2 times length times width, or base times height, and our base of this figure here is the same as this one here, which is a length of B, and it has a height of h, so this would be BH. Plus 2 times the area of figure 2 of side 2. So this has a length of A, because this and this have the same length, and it has a height of h. Part C says write an expression that represents the lateral area of the right pentagonal prism as the sum of the areas of its lateral faces. So again, same approach. Let's take a look at our figure and see what it's made of. So this is a right pentagonal prism. Notice it is a pentagonal, which means 5-sided prism. And so there are 5 sides on this, and they are not necessarily all the same length. In fact, it tells you that first we have length A, B, C, D, and E. So we're going to assume that all of the lengths of the sides of this pentagonal prism are all different. So when we find the faces, we need to find all separate areas. So when labeling this figure, we have face 1, which is this one right here. Face 2, which is this one back here. Face 3, which is this one back here. Face 4, which is this one on the side. And face 5, which is the entire front side here. So my approach here is to find the area of each one of these sides and add them all together. So going through again, you'll notice that these are simply rectangles. So we're going to do base times height. So our first one here is B times H. Our second one is C times H. Our third one is D times H. Then E times H, and finally the front side, which is A times H. What value appears often in each expression and why? So as I look through all of these, we have the different lengths, but what's in every single one of these is the value of the height. So let's actually take each of our parts A, B, and C and factor out the height so we can see what would be left. So if I divide out height and put it out in front, so we're basically doing the opposite of the distributive property. If I took H out of this, we'd be left with A. If I took H out of this, we'd be left with B, C. And so you can see if I multiplied this back in that we get what we started with, so that's how you know that we did it correctly. Looking at this one, let's factor the H out in front. What we'd be left with, if we took the H out, we'd be left with 2B. If we factor the H out of this one, we'd be left with 2A. And factoring the H out of this one leaves us with H times B plus C plus D plus E plus A. Looking back at all of these, what I notice here is that what's left inside the parentheses is actually a perimeter. So looking back at our figures here, if I wanted to find the perimeter of the base, in this case, I would do A plus B plus C. That's exactly what I have here. So this is really height times the perimeter of the base. For this one here, we have 2A and 2B, but if we look back at our figure here, we would have added A plus B plus A plus B. So another way to say that is 2A plus 2B. So again, we're seeing that same pattern of height times perimeter of our base. And you can see in the last figure that that pattern continues here. If we rearrange this and put A first, we'd be adding A plus B plus C plus D plus E. And that is exactly how we'd find our area here, A plus B plus C plus D plus E, which is basically the perimeter of our base figure. So to summarize, the common factor was height. And if you factor out, you will find that every time The lateral area is found by multiplying the height times the perimeter of the base. Example 2 says the pyramid in the picture has a square base and its lateral faces are triangles that are exact copies of one another. Find the surface area of the pyramid. When we are asked to find surface area, what they're asking us to do is to add the area of each face on the figure. And when we're talking about the faces of the figure, we're including the base or bases of the figure. So in this case, we only have a single base, and then we have 4 triangles that make up the other faces. So in general, surface area is the sum of the area of each face. So in this case, if I want to find the surface area, my approach is to find the area of the base and add on the area of the 4 identical triangles. Now, since they are identical triangles, we're really doing repeated addition, and so we can summarize that as multiplications. Then, since there are 4 equal triangles, we can do 4 times the area of one of the triangles. So let's plug in what we know. The area of the base is actually a square in this case. You can see that it has a length of the side of 6, so the area for this would be side squared. And we know that we're going to do the area of the triangle, which that formula is 1/2 base times height. So in this case, the side is 6, so this is 6 squared, plus 4 times 1/2 times the base. In this case, the base of the triangle is 6. Times the height of the triangle is 7. One thing I want you to be careful of, sometimes they will give you the length of this side of the triangle, but that is not important when calculating the area. You have to use the height of the triangle. Now, if this were a right triangle, in this case right here, then we could use the length of the side, but that's not what's going on here. Six squared gives us 36. Then we have 4 times, I would do 1/2 of 6 to give me 3, and 3 times 7 is 21. And so when I multiply those two, we get 36 plus 84 for a final answer of 120 centimeters. And this is surface area. If we're finding area, it's still squared, not cubed. In this lesson, we have learned that surface area of a right prism can be obtained by adding the areas of the lateral faces to the area of the bases. And we learned that a lateral face are the sides that create the figure but excludes the top and the bottom base figure. A right prism is basically created by taking a figure base and stacking it repeatedly to create a 3rd dimension of height. A cube is a right rectangular prism, all of whose edges are equal length. Surface, the surface of a prism is the union of all of its faces, the base faces and the lateral faces.